Hi, welcome to lesson 4.1 for the honors class, or lesson 3.1 for the regular chem class. We're basically just going to be counting atoms today. We're going to be looking at chemical formulas and then adding a couple of things as we go along. It's a really short, really simple lesson. But the first things that we need to do is define a chemical formula. We've been writing chemical formulas for quite some time already, but I know it's been a while since we've actually talked about it. So a chemical formula is a string of elements, and these are written as element symbols. That make up a molecule or a compound. Now, there doesn't necessarily have to just be one element symbol or one element. We use this term subscripts to represent the number of each individual element. Okay, and then some examples of chemical formulas. We've seen a lot of these, but like H2O, H2SO4, CO2. These are all examples of chemical formulas. You can see here we have element symbols, we have subscripts, all of that good stuff, okay? So the first thing we want to do is just counting atoms in molecules or compounds. Basically, we will have a big sort of symbol. This is the element symbol. This is telling us what element it is. And then we'll have something next to it. This is the subscript. And this will be a number between 1 and, infinity, kind of telling us the number of each atom. Okay, or each element. Very important, if there is no number, then it's 1. And I realize that there's a mistake here. This should actually say 2 to 100. Because if there's no number, then there's only one of those atoms, okay? Some examples are like C3H5O7 and Mg3O8. If we're counting the individual atoms or individual elements here, in the first one we have 3 elements. We have carbon, hydrogen, and oxygen. In the second one we have magnesium and oxygen. We can see here that the carbon has 3. Just looking at the subscript, it's very easy. Hydrogen has 5. Oxygen has 7. So you match the element symbol with the correct element. You dictate how many it has because it tells you how many it has. So very, very simple. Now, this is the first of 3 parts of this lesson. Let's do counting atoms in molecules or compounds with a parentheses. We don't want to forget that some molecules have parentheses inside them. Okay, and if something's in a parentheses, this is usually a polyatomic ion. It is a multiple atom, or it is a structurally attached molecule. Okay, which basically means that it is in the parentheses because it cannot be separated. Okay, this is very important. It has to stay together. And usually it's a mix or a bond of two or more elements. So it's usually like a molecule in there, and it can't be separated, or there's a reason why it's in the parentheses. But let's figure out how to count this. So let's look at a counting example. Let's look at SrOH2. We should recognize that in here, we have hydroxide, which cannot be separated. Okay. Anything outside of the parentheses, all you have to do is look at the subscript. In this case, the subscript is 1. We have 1 strontium. But when something is inside the parentheses, remember it's probably going to be more than one element. And I'm just going to pull this out of here. Okay. We want to look at each individual subscript. In this case, each subscript's 1, and we want to multiply that by the subscript on the outside. That's going to give us the total number. So for oxygen, we have 1 inside the parentheses multiplied by 2, which is outside of the parentheses. We have a total of 2 oxygens. Not 20, 2. Same thing with hydrogen. There's 1 inside the parentheses times the 2 out. So we have a total of 2 hydrogens. 1 strontium, 1 oxygen. 1 strontium, 2 oxygens, 2 hydrogens. If we look at another example, let's say we have, something like Cr3, C2, H3, O2, and then we have a 6 on the outside. Chromium is not part of the parentheses, so we just look at the subscript, we have 3. But we also need to calculate the numbers for hydrogen, carbon, and oxygen. What we're going to do is we're going to take this number and we're going to multiply it by the number on the outside. So we have 2 times 6, that's a total of 12 carbons. Same thing, we have 3 times 6, that gives us 18 hydrogens. And then again, lastly, we have for the oxygens 2 times 6, which gives us a total of 12 oxygens. The last thing we're going to do is we're going to do counting atoms in molecules and compounds with coefficients. If you've ever balanced a chemical equation, you've probably seen something called a coefficient. If you have not balanced a chemical reaction, don't worry, because that is our next lesson for both classes. A coefficient is a whole number written in front of a molecule or compound for atom balancing purposes. We're going to learn next time that there's something called the law of conservation mass, or the law of conservation matter, which says that matter cannot be created or destroyed in a chemical reaction. So coefficients help us balance chemical reactions to make sure we have the same thing on both sides. And we'll eventually learn about molar ratios and molar theory, which has to do with why coefficients exist. But all you need to know now is how to count them if they have a coefficient. And the way that we do that is, first we want to get the total number of each element in the compound or molecule, whatever you want to call it. And then we're going to multiply it by the coefficient. And this will give us the grand total of each element. Remember that there can still be parentheses. The parentheses come before the coefficients when we're calculating it. So let's look at a few examples. Let's do an example without a parentheses, and let's do an example with a parentheses. Okay. So in this case, we have carbon and oxygen. We have one. If I'm completely ignoring the coefficient, that's totally fine. We have one carbon without the coefficient. Total number without the coefficient, we have 2 oxygens. Now we want to multiply each of these numbers by the coefficient that's here. So in total, I have 6 carbons and I have 12 oxygens. And the last one, probably the most complicated one that we're going to do, we have nitrogen, hydrogen, and oxygen. Notice that we have 2 different areas or 2 different let's just do areas of where the hydrogens occur. So let's completely ignore this for now and let's count the number of molecules we have. We have 1 nitrogen. Here we have 4 hydrogens. So we took care of this, we took care of this. Here, it might look like we only have 3 hydrogens, but remember when we have it in the parentheses, we need to multiply. So the total number of hydrogens we have here is 10. So we have 10 hydrogens. And then we have 1 times 2, 2 oxygens. Now we can multiply all of these by the coefficient in the front, and we should have 5 nitrogens, 50 hydrogens, and 10 oxygens. Okay? We want to make sure that we can do this really quickly because next time we're going to be balancing, and it's really important to know exactly how many of each specific element is in a compound, whether it has a parentheses, whether it doesn't, whether it has a coefficient and a parentheses, whether it has one of each. It's really, really important. We need to be able to do this quick. So that's all I have for you.